Alright, section 5.5, slope. As is described here, pay attention here, slope is the rate of change between any 2 points on a line. To find the slope, you find the change in y and you put it over the change in x. This is often nicknamed the rise over the run. Basically, if you pick any point on a graph and you go up and over to get to another point, you can figure out its slope. This is just an example, and I'll do more of this, but if I look at these 2 points and I want to know what that slope is between them, if you see here, we went up 1, up 2, and we went over 3, 1, 2, 3. So my rise over my run, my change in y is what we went up, because remember, this is the y-axis right here. This is my x-axis, so up y over on the x. Obviously, then that becomes 2 up, 3 over, so it becomes 2/3. This is a positive direction, so I went up and I went over a positive 2/3. Alright, we got a couple graphs here we can figure out the slope of the line with. I start at 0, 0 right here, and I'm going to go to this point 3, 4. Now remember, it's the change in y over the x. So I'm going to go up 4, and I'm going to go over 3. Now they went this way, but it's the same thing either way. I'm going up 4, and I'm going over 3. So my slope then is the rise over the run. The rise of 4 and the run of 3. This one, a little different because I'm in a negative, negative 2, and I'm going over to 4, 1. In this case, I went up 3, and then I went over 6. So it's a rise of 3 and a run of 6. However, we can reduce this. 1/3 obviously reduces down to 1/2. So that would be my answer in this case. If you look, by the way, you could have done it in other spots as well. It didn't have to be the 2 points that I just did. If I would have picked this point and I went up 1 right here and then come over 2, sure enough, I'd been on the graph as well. Up 1 and over 2, I'd have been on the graph as well. Up there, up 1, over 2, same thing. Either way, it works wherever you are. A rise of 1 and a run of 2. By the way, while I'm thinking of it, you always keep, I'm sorry, I just erased that. You always keep an improper fraction for slope as it is. Don't put that into a mixed number. It wouldn't make sense for a slope in that way, so keep an improper fraction like that. Alright, let's look at some more example problems here. Look at A here. We got a point 0, 0, and we got a point 6, 2. If I go up 2 and then over 6, that would be my change in y over change in x. My change in y, as I just said, was 2, and my change in x is 6. We, of course, can reduce that down to 1/3. And, of course, if you look here, if I would have gone up 1 right here and then gone over to this point, sure enough, that is a change of 1 over 3, so a slope of 1/3. At the bottom, I have a point here and a point here. I have a big change. That's a change of 6. And my change in x going this direction is 1, 2, 3, so a change in 3. Now, I did say that you should never put things into mixed numbers, but in this case, I would reduce this down, and 6 divided by 3 is 2. Now, you're going to say, well, what is that as a fraction? Well, remember that any whole number you can put over 1, and sure enough, if you look at this, if I change something and go up 2, and then I come over 1, that's 2 over 1. Again, up 2 over 1. Up 2 over 1. So I did that each time. So you would, just to simplify things, you would write just 2 as a slope here. So 1/3 and 2 would be my slopes here for A and for B. Alright, I'd like to find the slope of the line for these two problems and reduce if needed, and have those ready to go for tomorrow. Thank you and have a good night.